Hello, this is Joe Hacker. I will help you to become a quant. You ask yourself how to determine the price of a European call options with dividends based on a 6-step multi-period binomial model. Well, here are 10 steps how to do so. Let's get started. Step number 1. Determine the input factors. So we go into our model and type in as price of the underlying, it's 70 euros. The implicit volatility, 30%. The strike price is 68 euros. The risk-free rate we set up as 1%, and the dividend is 4.85%. And last but not least, we consider the majority to be 1 year, i.e. 12 months. This was step number 1. Step number 2, derive the formulas needed for the calculation. Well, here you go. We're having the formula for the up factor, and the formula is e to the power of sigma, i.e. the standard deviation, and then the square root out of 1 divided by 12, i.e. 12 months. On the other side, the formula for the down factor, it's the same formula, however, the sigma becomes minus sigma. You can also calculate the formula by saying 1 divided up. So after this one, we come to the monthly risk-free rate, and that is the 12th root out of, open the bracket, 1 plus risk-free rate, close the bracket, minus 1. Step number 3, determine the up and down factors as well as the pseudo probability. Well, we need the following formulas. Here, they are pointed out here, and we are applying them now in Excel. Because we have a multi-period binomial model, we need to ask ourselves now, how many steps are we carrying out? And we know, we said at the beginning, we want to have 6 steps. 6 steps, 12 months, i.e. every second month a step is being made. So if we want to know now the up and down factor based on a 2-month period, this one becomes 2 divided by 12, because 2 divided by 12 is 1 divided by 6, i.e. 6 steps. So we're applying these formula now in Excel and calculate the up factor. The up factor equals E, and then we multiply it by the implicit volatility times the square root out of 2 divided by the majority in month, and close the bracket, and here's our up factor. Now comes the down factor. We basically can copy that and paste it in, and this time it's minus sigma, minus the implicit volatility, and the result is 0.885. Now comes the risk-free rate, and as pointed out in the previous step, the risk-free rate equals 1 plus my risk-free, my risk-free rate, my annual risk-free rate, basically, to the power of, open the brackets, 2 divided by the maturity in month, close the brackets, minus 1, close the entire formula. And then we know our risk-free rate annually was 1%. Our 2-month risk-free rate is 17%. Okay. Let's continue with step number 4, calculate the share price development. Here we go. We know in T0, the share price of our pharma group share is 70 euros. And now, if the share price goes up, we multiply 70 times the up factor, and here we multiply 70 times the down factor. What we do next is we fix the up and the down factor, because that stays always here with the dollars. There we go. And the previous share price, we don't fix, we leave variable. So now we can grab cell C29 and move it up there. We take that cell, move it all the way to column H. We do the same for the first up result, move to column H, and then move up to row 22. Same thing we do for cell C29, move it to column H, and then move it all down to row 34. And you see, we already built our share price development. Step number 5, build in the dividend. We assume that the dividend will be paid in the middle of the year. The year has 12 months. We have 6 steps, so it will be paid after 6 months, i.e. step number 3. We will model in the dividend by clicking on the formula in step 3 and multiplying this times 1 minus the dividend. Then we'll fix the dividend with dollars, and we can take it and pull it down to row 29. And our last cell, we do manually 1 minus the dividend. And then we are done with our share price development. Now comes step number 6, format the share price development. Well, this doesn't look so nice here. Therefore, we can use the format painter and format it with the format painter. Still doesn't look so nice because we have all those zeros in between. Therefore, we click on format cells. We click on custom. And we are looking for a formula that looks exactly like this. And we press OK. And then we are done formatting our share price development. Step number 7, calculate the intrinsic value of the call in period 6. So what we do is we move from the share price development to the option tree. In cell H42, we point out the intrinsic value. Is the option in the money, at the money, or out of the money? Basically, by doing the following manually here, 138 euros minus the strike price is 70.88. And so it's in the money, and we move down from the positive outcome to the sort of negative outcome. And we move from the option in the money to at the money to out of the money. So we don't do that manually, but we're using an if formula. And the formula is if the positive share price development results in a value that is higher than my strike price, which is indicated here in D8. And we, of course, fix the strike price with dollars. If this is the case, then, of course, we want the outcome of the positive share price development minus my strike price. And if this is not the case, if the option is not in the money, but out of the money or at the money, we want the 0. So this is the formula leading us to 70 euros and 88, same as I did just before. So what we can do now, we just grab it and move it all the way down. And then we see the further we go down, the worse the share price development was. The closer the intrinsic value gets to 0, but it never can get negative. So this cell we changed. There's another cell we need to change because the positive and the negative outcome will now be discounted using the so-called pseudo probability. Well, how can I calculate the pseudo probability? I can click on cell D17 and type in equals 1 plus my risk-free rate minus my down factor, close the bracket, divided by the up factor minus the down factor, close the bracket, and this is my pseudo probability. So now I'm using that to discount the two outcomes of my call. So how do I do that? Well, I'm saying equals the positive outcome times my pseudo probability plus the negative outcome times 1 minus the pseudo probability. And you see exactly what I've done here. I basically calculated the expected value of the two possible outcomes. And that part is now being discounted from period 6 to period 5 by 1 plus the monthly risk-free rate. And I close the bracket and press return. That's the result. Now I want to pull down that cell, so I need to make sure I fix all the figures I've been using here, i.e. the risk-free rate and the pseudo probability. They need to be fixed. So where is it? Pseudo probability D17 needs to be fixed. There it is again. and the interest rate, the monthly interest rate, the monthly risk-free interest rate is being fixed. So having done that, I can quickly create my option tree by grabbing cell G43, pulling it all the way down and all the way up to column B. And then you see the result is €7.50. However, we want to do some formatting, and we now want to format the entire option tree in step number 10 by doing the following. We just basically can go to our already formatted share price development, use the format painter, and then we just delete the item. There are various ways of doing it, but that seems to be the quickest way. So we are done with our calculation of our European call option with dividend here in in step 3. And the result is €7.50. Ladies and gentlemen, I hope you enjoyed the video. In our next video, we move forward from 6 steps to 12 steps. Enjoy.